Hi, Pre-Calc. This is Miss Jensen. We are going to talk today about completing the square, and you can see at the top, it's a prereq for Chapter 10, which is conic sections. Well, completing the square is a way of, we can use this method to solve quadratics. Like quadratic formula is a way we can solve. We can solve by factoring. So there's other ways we can solve quadratics, but we can also use completing the square. Honestly, it's a really impractical way of solving equations. So I don't know that we would even teach it unless we were doing conic sections, but we do need to kind of understand the basic steps of completing the square, because with conic sections, we want to take equations and put them into standard form so we can graph them more easily. So just an example of a quadratic that's in standard form. This is this, and we would here we're putting it into vertex form. So I guess when I say standard form, I mean standard form according to circles, ellipses, etc. We'll worry about that later, but that's why we're talking about conic sections. These are the steps. So I'll just talk through these quickly, and then I'll kind of bounce back and refer to them. We move the constant or the number to the other side if we need to. And then if there's a number in front of one, we're going to factor it out or divide everything by that coefficient. Now, when we do it with conic sections, we actually factor it out. Here, we're probably just going to divide everything by that. I'll show you in just a few minutes. Then we're going to take half the middle number, then square it, and then add that to both sides. We're going to factor the new perfect square trinomial and solve. All right, so before we do some of those, we're just going to look at some perfect square trinomials. So the first step in completing the square really is we're creating perfect square trinomials. Perfect square trinomials are where the last term is a perfect square. Okay, this last term is a perfect square, right? 3 times 3, 4 times 4, 6 times 6. And the middle number is the square root of that last term doubled, okay? So when we're completing the square, we're creating perfect square trinomials, and then we're factoring them. So the reason I want to show you this step is because if we don't, people get a little confused about how we get from step 2 to step 3 or step 3 to step 4. All right, so if I'm factoring this, remember, if this is x squared, I would put an x and an x here. And then I think of two numbers that multiply out to be 9, add up to be 6. And that is positive 3 and positive 3. And because it's positive 3, we're going to put plus 3 plus 3. Okay. Here, this is x squared, so it'll go x times x. If I ask myself what are two numbers that multiply out to be 16 and add up to 8, we get 4 and 4. So this becomes, again, positive 4, positive 4. And then if we look at 36, what are two numbers that multiply out to be 36 and add up to negative 12? It's negative 6 times negative 6. Negative 6 plus negative 6. And I guess got to remember the x there. Now, another way I can write all of these is because basically both of the binomials are the same. I could rewrite this as x plus 3 squared and x plus 4 squared. And that's what we're going to do here, is we're going to rewrite it as a binomial squared. But what ends up happening is we kind of skip from here to here. We skip to this step. And so again, a lot of times people are like, hey, what happened to the negative 12? Well, we're really just skipping this step. So I wanted to show you really what's happening when we jump from the first step to this, for example. Okay, so the steps. Remember, step 1 was get the constant on the other side. So I'm going to minus 4 on both sides. So this becomes x squared minus 12x, excuse me. And I'm going to leave myself a little space on both sides, because now step 2, so move the constant if you need to factor out the coefficient. So if a is not -1, it's not. It's just plain old x squared. So I'm going to go into step 2. I'm going to take half the middle term, then square it. So I'm going to take half of this middle term, half of -12. So -12 divided by 2 is -6, right? And I'm going to square it. And I'm going to add it to both sides. All right? So a lot of times I'll say we half it, we square it, we add it to both sides. Well, that's step 2 into step 3. So now what we just did is we created a perfect square trinomial, just like this. This is what we have here. X squared minus 12x plus 36. But instead of doing that middle step, it always turns out to be this x and whatever this number is, squared. X minus 6 squared. Because remember, if I factored it, if I wrote the whole thing out, this is what I would end up with. So I'm kind of skipping that middle step from before. Then this is -4 plus 36. So that's 32. And we'll take the square root of both sides, x minus 6. Now, when I take the square root of a number, I'm going to put a plus and a minus there, because like the square root of 36 can be +6 or -6. The square root of 32 can either be positive or negative. And then I just want to finish solving. So solving just means to get x by itself. So we end up with 6 plus minus 32. And we'll leave our answer like this. This is more typical of how we would leave our answer for conics. Now, if we were going to solve that, if I really wanted to, I could leave my answer solved like that as well. But just remember, with quadratics, there's 2 solutions there. Square root of 32 is about 5.7, 5.7. So really the 2 answers here are 6 plus 5.7 and 6 minus 5.7. So approximately 11.7 and 0.3 would be the solutions. However, we're just going to leave it as a square root like that. And a lot of times when we're trying to find the solutions toward quadratic, if that's our purpose, we would leave it like this anyway. But, I think it makes more sense because it's 2 solutions to split it up. But again, we're not doing that today. Okay. So for this one, I'm actually going to change this to a 3, I think, just to get an odd number in the middle. So we'll just change this to a 3. So I just changed the problem. But now I'm going to follow the steps. I'm going to step 1, I'm going to get rid of this 7. So that crosses off, and I'm left with 3. I'm going to add a blank there, because then step 2 is half it and square it. So what is half of 3? I could write it 2 different ways. I could either just leave it 3 over 2 and square it. In this case, I think we'll actually take 3 divided by 2 and we'll do it as 1.5. You can do it either way. So a lot of times we would keep it 3 over 2 and square it. All right, but we'll do decimals, and that's the way it is on the answer sheet on the worksheet. So this is x and positive 1.5, right? We kind of take what half of positive 3 is positive 1.5. So this becomes x plus 1.5. Remember, this was squared. I dropped that before. So 1.5 squared is 2.25. That's 2.25. So if it's 2.25 plus 3, that's 5.25. Take the square root, both sides. So the square root cancels out the square. And now we're going to solve. So to solve, I'll minus 1.5 from both sides. And again, I like to put this in front, this negative 1.5. And that's typically when we do the conics, we'll usually have the number plus or minus the radical. It's not wrong to have the radical first, but it's just more convenient if we're actually trying to find what the solutions are. Okay, we're going to just do a couple more here where the situations are a little bit different. So just, again, reminder, we start out by moving the constant, that number, to the other side. So I add or subtract that. And then here, if A is not 1, you need to factor out the coefficient or divide everything by that coefficient. So A is not negative 1 here. We have a number in front of x squared. So in this case, we're just going to divide everything by 3. If I divide everything by 3, we end up with x squared minus 4x plus 1/3 equals 0. So we kind of end up with something similar anyway because we have a 0 on the other side. Now, when we do conics, just a little heads up, we, instead of dividing by 3, we'll probably do this. We're going to, factor it out for a different reason, but we'll talk about that little switch when we actually do conics. All right, so now I'm just going to go through the regular steps. I'm going to minus the 1/3. So I'll minus 1/3 from both sides. And I'll leave my little blank. And then I'm going to half it. Take half of negative 4. Oops, something came up there. Half of negative 4, which is negative 2. See, if you take half of that and put it in as a positive or negative, then everything's set up. So we half it, we square it, we add it to both sides. So once we get the constant on the other side, step 2 and step 3 are just we half it, we square it, we add it to both sides. All right, enough of that. This is x minus 2 squared. And then here, again, it's like, okay, this is negative 1/3, and this is a 4. So, I could find a common denominator and rewrite it as a radical, or I'm sorry, as a fraction. But I think instead we will change this to a decimal, negative 0.33, and we get about positive 3.67. Okay, so we'll just leave our answers with decimals under the radical. We're going to take the square root of both sides. And the rate is positive, negative. And then finally, we would add our 2, which crosses off here. And then usually we like this 2 in front. Oops. We like the 2 in front. 3.67. Okay, so there are 2 solutions there. So if we wanted to actually find out what the 2 solutions were, and of course we could do this using quadratic formula also, but I would take the square root of 3.27, and it's about 1.8. So I would do 2 plus 1.8, 2 minus 1.8. And so my 2 solutions are about 3.2 and 0.2. But here we're just going to leave our answers like this. We're not actually going to be finding the solutions when we do conic. Okay, I want to do one last one for two different reasons. First of all, it's one more example where there's a coefficient in front of x squared. And the other thing is we get an imaginary number in the end. And it's probably been a while since you have worked with imaginary numbers. So we'll just remind ourselves what that looks like. So I'm going to start by getting rid of that 4. So I'll divide everything by 4 because we want a lead coefficient of 1. Now I could have gotten rid of the 36 first. I think in the steps, I'll show that I'm doing the right side by 4 too. We get 0 either way. I could have minus 36 first. It doesn't really matter because either way, once I minus the 9, once I minus that, I get negative 9 on the right anyway. We're going to put a blank on both sides. Same steps. We're going to half it. So half of 2 is 1. We're going to square it. We're going to add it to both sides. And then I'm rewriting this as a binomial squared. So this is the x, this is the 1. So again, people always ask, what happened to the 2? Well, remember back here, really what we're doing is, when we're factoring this, we're skipping that middle step. But if I wrote out x plus 3 times x plus 3 and multiplied it out, I would end up with this original problem there. And same here, if I wrote out x plus 1 times x plus 1, and I did all this, I would end up with x squared plus 2x plus 1. I'm going to erase that because it's very messy. But just so you know, that 2x is there when we multiply it out. Okay, so this is negative 9 plus 1, which is negative 8. I'll continue on my normal way. Take the square root of both sides. X plus 1 is positive negative, square root of negative 8. All right, so this is why I wanted to do this one, is because we have the square root of a negative number. And remember, that negative on the inside is the same as an I on the outside. So I just replaced that square root of negative 8 with an I. That's an imaginary number, so we got to take that negative out. All right, but then I'm going to do the same thing. I'm going to minus 1 from both sides. This is x equals, and again, I want that negative 1. I don't have to have it first. I could do plus minus I square root of 8 minus 1, but usually we put the integer first. So negative 1 plus minus I square root of 8. All right, that's it for completing the square.